This video looks at National 5 calculation questions. Specifically, in this video, we're going to be looking at percentage by mass calculations. So percentage by mass calculations are one of the ones that students find most difficult, but actually which are the most easy when you have a look at it. If we start by looking at the worked example, so we're calculating the percentage by mass of iron in iron 3 ethanoate. We start by finding the GFM of iron ethanoate. So when we draw this out as our pipe diagram, we can see here we've got within the ethanoate group, we've got 1, 2 oxygens. So we've got 3 ethanoate groups here. So that 2 times 3 gives us 6 oxygens in total. If we look to our data booklet, which we have up here, we can see that oxygen has an RAM, relative atomic mass, of 16. So in this case, we're going to have 6 times 16. We're then going to have 3 hydrogens, but we've got 3 times that, so it's 9 hydrogens. If we look at the table again, we find out that hydrogen has a relative atomic mass of 1. So that's going to be 9 times 1, which is going to give us 9. We can see we've got 2 carbons within the ethanoate group, which times 3 will give us 6 carbons in total. So 6 times carbon, which is 12, will give us around 72, I imagine. We then have the iron itself, which when we go to the data booklet, page 7, iron is 56 in terms of relative atomic mass. So when we join all that together, we get iron ethanoate's GFM of 233. And you can see here the working we have for that. The relative atomic mass of iron is 56. So what percentage by mass means is how much of the mass by proportion, so percentage, is made up of just the iron bit. So if the iron itself is 56 and the total mass is 233, we take 56 divided by 233 and then times that by 100. So 24% of the mass, just under a quarter of the mass, is iron. And if we look at it, 56 could easily be about a quarter of 233. Going through these examples here, so ammonium carbonate has a grams formula mass of 96. What is the percentage by mass of nitrogen in ammonium carbonate? So luckily here, the 2025 question was multiple choice. So in ammonium carbonate, we see we have 1 nitrogen in the ammonium, but we've got 2 of them of that group here. So 2 nitrogens in total. When we look at our data booklet, nitrogen's 14. There we go. Relative atomic mass of 14. So 2 times 14 will give us 28. So based on our worked example up here, we're probably thinking it's going to be 28 divided by something, and that tells us it's B off the bat. But let's just keep playing through. So the grams formula mass of ammonium carbonate is 96. So 28 divided by 96 times 100. The rest of them we'll just go through without doing too much of the working. So the percentage by mass of lead in lead sulfate. So we take the GFM of lead sulfate, we go to our data booklet again, we'd find they've got 1 lead, so we'd find out what lead was in terms of relative atomic mass. We've got 1 sulfur, so we'd add on the relative atomic mass of sulfur, and then we've got 4 times the relative atomic mass of oxygen. So oxygen's relative atomic mass is 16, so we do 4 times 16, which is I think 48. When we join all that up together, we get 303. Yes. So lead on its own is 207. We can get that from the data booklet. Divided by 303, which is the overall mass of lead sulfate, and times by 100 gives us 68%. The percentage by mass of nitrogen and nitric acid is a similar method. So we find nitrogen, go to the data booklet, it's 14. Add on the 1 for hydrogen and the 48 for oxygen, gives us 63 total. When we do 14, which is the relative atomic mass of nitrogen, divided by the relative atomic mass, I'm getting good at saying this, of the entire compound, we get 22%. So you can see a lot of these questions are more or less identical. We've got the element that is telling us to look for the relative atomic mass of, then we've got a compound which we need to find the overall GFM. So it's the relative atomic mass of the thing they've asked for, divided by the GFM. Obviously being careful that in, for example, the next question, the element they've asked us to look for, we can't just take its relative atomic mass, we have to work out how many we have. So calculate percentage by mass of hydrogen in diammonium hydrogen phosphate. So in this case, we've got one hydrogen here, and then we've got 4 times 2, so we've got 8 hydrogens there. So we've got 9 hydrogens in total. Our data booklet will tell us that hydrogen has a relative atomic mass of 1. So that means that we have an overall mass of hydrogens in this compound for 1 mole of 9. If we take the whole GFM of the compound, we get 132. So 9 over 132 times 100 is 6.8. Again, in urea, it's 4, because it's 2 times 2 is 4. So it's 4 divided by the overall GFM for urea, which gives us 6.6. Ammonium phosphate has a grams formula mass of 149. So we know that 149 is going to be what we're putting at the bottom of our dividey sum. The percentage by mass of nitrogen in ammonium phosphate is, well, we've got 3 nitrogens. We maybe happen to remember that nitrogen's got a relative atomic mass of 14. So 3 times 14 will give us 42, divided by 149 times 100. Calculate the percentage by mass of aluminium. So again, what is aluminium's relative atomic mass? Times it by 2, because we've got 2 in the compound, and then take the GFM of the overall compound, including the aluminium, and it will give you 13.4. Calculate the mass of silicon in andalusite. So we've got 2, so we've got 1 silicon. Go to our data booklet, page 7, it'll tell us the GFM of silicon, divided by the GFM of the compound as a whole, and it gives you 33%. Copper can be extracted from its ore, malachite. It's a hefty looking compound, but we're okay. Calculate the mass of copper in malachite. So this one's a bit more tricky because we've got the 2 coppers here. So it's going to be whatever 2 times the relative atomic mass of copper is, and then divided by the overall GFM of malachite. And that will give us 57%. So even though this is a fairly hefty bit over here, we're making sure we've got 1 carbon, 3 oxygens, another 2 oxygens, and then 2 hydrogens. It's still coming out as over 50% copper. Urea can be used as a fertilizer. Percentage by mass of nitrogen urea. We're getting good at this now. So we've got 1 nitrogen, 2 nitrogens. 2 times 14 is 28. So it's 28 divided by whatever the GFM of the overall compound is. So as you can see, this goes all the way back to the specimen from 2025. It's a really good one to start on if you're doing calculation questions, because it is just so point and click. It's the same thing every single year. So hopefully that helps. If you're struggling, please do contact your chemistry teacher for more assistance.